And dividing is kind of funny. There's a property that says, and I'll write this at the very top, that says if you're trying to take the square root of a fraction, let's say a over b, then that's the same as taking the square root of a over the square root of b separately. And I'm going to actually come back to that because you actually already know this via your exponent rules. The square root of something is the same as raising it to what power did we recently talk about? The 1/2 power. Very good. So square root of a over b is the same thing as that. Your exponent rules of parentheses already tell you this, right? If you have a fraction being raised to an exponent, you raise the numerator to it and you raise the denominator to it. So you actually already kind of know this property if it's given to you in exponential form. But here we're going to keep it all in radical form. And it looks like this. And what's funny about this is that you can use it either way to your advantage. If they're already together, you can split them up if that's going to be helpful. If they're already split up, you can go back and write them as a single fraction under a radical if that's going to be more helpful. And right in the first two examples, you're going to see that. So in number 1, it's already written as the square root of a full fraction. It makes sense to split it up into root 121 over root 9 separately because I know the square roots of those separately. Square root of 121 is 11. Square root of 9 is 3. I'm done. Number 2 is already separated. But do you know the square root of 72x cubed? No. Do you know the square root of 8x? No. You could break those down, but watch what happens, obviously, if I kind of just, instead of having two separate radicals, and I just write a single fraction underneath, what does your instinct tell you? Oh, shoot, I should now do this. Simplify the fraction, right? So 72 divided by 8, it's all still going to be under a radical, but 72 divided by 8 is 9, and x cubed divided by x is x squared, right? Your exponent rules. If you're dividing common bases, we subtract the exponents. And now this is really easy, right? What's the square root of 9x squared? 3x. So it works both ways. You want to look at that first to see if either of those can be used to your advantage. Do you think it would be helpful to condense this into a single fraction under one radical? Yeah, because I see 500 will divide by 10. So, you know what, you can do this all at once. You don't have to split it up. I can write my single radical, and I can do what's 500 divided by 10? 50. And x cubed divided by x to the negative first, think exponent rules here. X to the fourth, good, Mike. Because 3 minus negative 1. Now, the square root of x to the fourth I could do, but 50 I've got to break down. Root 25, root 2, and then I'm going to leave the x to the fourth for the moment. And that's going to give me a 5x squared, root 2.
Would it be wrong if you had 5 radical 2x squared?
If it was open response, no, but I can almost guarantee, well, let me tell you the risk of that, even if it is open response. Technically, no, but on a multiple choice, it will never appear that way. They're going to put all the solid numbers out in front, and then it's going to end with a radical. The risk with something like that is if you did 5 root 2 x squared, and it becomes like, is that under the radical or not under the radical? Because now the length of your radical is critical. If you're really careful about it and not sloppy, and you really end it at the root 2, no, that's not wrong. But it's going to be just more frequently written like that. All right, so now it gets a little bit trickier because there's a secondary piece here that I haven't mentioned yet. Now, what do you notice first and foremost when you look at this? Chloe?
The 4 isn't under a radical.
This is not under a radical?
Yeah.
Okay. Can you do anything to the problem, though, right away? Can you evaluate anything? No? I think you can, because I think you know the square root of 4, Chloe.
You can make it 2.
That's just 2, right? So if something like that just, jumps out at you, handle that first. And then just talking about like basic fractional stuff, 2 over 4 can reduce to 1 over 2, right? So we can make that now a 1 over 2 root 5. And now it looks pretty good. Except, does anybody know, I don't believe you've ever learned this, but I'm just curious, does anybody know what's wrong with that? Yeah. Correct. It is like improper for whatever reason in math to have a radical in your denominator. How did you know that? Does that sound familiar to anybody else? It does? So you think somewhere, maybe your Algebra 1 teacher talked about it quickly. Yeah, it is not okay to have a radical under the denominator. So that's what this process is, rationalizing. That is the process of getting a radical out from the denominator. And there's 2 different scenarios we have to talk about. Sometimes the radical is part of a monomial. When I say monomial, how many people get confused? Oh, good. Monomial just means single term. Here, when we get here, this radical is also part of a monomial. This radical is part of a binomial. Does everyone see what I'm saying here? So the way we handle the monomial ones will be very different than the way we handle the binomial ones. Okay? So rationalizing is almost like how we creatively get a common denominator. When you're trying to get a common denominator, you are technically multiplying your fractions by 1, correct? Let me just take a quick little example. 1/4 plus 2/3. Aren't you going to make them both 12? So you creatively multiply by 4 over 4 on this one? Isn't 4 over 4 just a creative way of multiplying by 1? It's going to change its appearance, but it's not going to change its value because you're technically multiplying by 1. So we've done this idea before of multiplying by 1 in a creative way so that we change the appearance but we don't change the value. And we're going to do that same thing here. So when it's part of a monomial, all you have to do is take that radical 5 and multiply by radical 5 over itself. We've multiplied by 1, so we're not going to change the value, but this will change the appearance and the radical will be gone from the denominator. On your numerator, 1 times root 5 is just root 5. On your denominator, Alexa, what's 2 root 5 times root 5? What happened to your root 5 times root 5? It's just 5, very good. So the 2 is there, and root 5 times root 5 is just 5. So what's the 2 that was there times the 5 that just came up? 10. And that's your answer. Now, one thing that might be wise for you guys to do to sort of check yourself, type that into the calculator. It's going to be a gross decimal. Type that into your calculator. It's going to be, hopefully, if you've truly simplified it, it should be the same gross decimal. Does that make sense? So it's a way of checking if you want. It's not really going to highlight where your mistake is. You'd have to go back and look through that. But it is a way of checking. So if I do, let's see, root 4 divided by, now here's one thing you have to be careful of. If I just do 4 root 5 right now, it's going to give me the wrong answer. Why? What's the calculator going to be doing if I write that it's not supposed to be doing? Anybody? The calculator is going to take, it does order of operations. It's going to take root 4 and divide it by 4 first, take that answer, and then it's going to multiply it by root 5. That's not what that presentation tells us, is it? So you need to make sure root 4 divided by your I didn't close my root 4 divided by, you need to make sure your denominator is encased in your own kind of self-created set of parentheses. Does that make sense? Because we know when we look at something like that there is sort of an imaginary set of parentheses around that denominator so it works as a unit. You need to make sure you do that. And then, so there's my gross decimal I was telling you about. Now if I just do root 5 divided by 10, it should match, and then you know you have the right answer. Okie doke. Any questions on that? Checking. Okay, number 5. This radical is still part of the monomial. I realize this one up top is part of a binomial, and I don't really care about that because this is the one I want to get rid of. So, Tess, what would I multiply by to get rid of that radical 17 in the denominator? Over. Correct. What makes this one slightly different now is that when we do multiply in the numerator, it's not going to be that easy, right? Here was just 1 times root 5. This is root 17 times a binomial, so I need to, starts with a D and ends with distribute. You guys. Negative 3 root 17. By the way, I don't think I do that with my son at home because he doesn't really get that joke. But we bought Snickers like Halloween candy last night, and he saw me buy it, so he got in the car and he said, "Mommy, I would like a snack, please. It starts with Snick," is what he told me. I thought I was dying. I thought that was the funniest thing in the world. You guys, not so much? No? All right. I'll tell Mrs. Brzanti. Maybe she'll think it's funny. Negative root 2 times root 17 is going to be negative root 34. On my denominator, I've got the 3, and then root 17 times root 17 is just 17. 3 times 17 is 51. Now, sometimes, and it didn't happen in the first one, did it happen here? When you multiply through, you've created a need to simplify. Can I simplify root 17? Can I simplify root 34? What do you think about that? How many people think, I think we all will agree that 17 can't be simplified. How many people think I can simplify root 34? How many people don't think I can simplify root 34? How come nobody knows? Elena? What are you checking on your calculator right now? So how are you checking whether or not 34 can be simplified?
Dividing it by perfect squares.
Like 4 and 9 and 16, and so can it be simplified? No. Right. 34, you could break it down into root 2, root 17, but do you know the square root of 2? No. Do you know the square root of 17? No, so that's not helpful. It's only if one of those perfect squares go in, which it does not, so we are done. And it's funny that that's actually referred to as simplifying, isn't it? Like if I just focus you back on the original problem, usually simplifying makes the expression look simpler, but not here. But because there's this weird rule in math about rationalizing. Okay, on 6, for those of you who remember rationalizing a little bit, did you ever do it with binomials? Does anyone have a gut instinct as to what you would do here? Okay, tell me if you know what this word means. Or how to say it. Conjugate would be the verb. The noun would be conjugate. But yeah, I don't ever know if conjugate is actually a verb that can be used. But if you want to conjugate something, maybe. But normally we say you would multiply by the conjugate of that binomial. Does anybody know what the conjugate of that binomial is? Raise your hand if you've heard of the word conjugate. Do you know what it means? How so?
It's negative root
Yes, but if you only can conjugate, I'm using it as a verb now because of you, thank you very much. You can only conjugate binomials, which means if it's a plus b, you make it a minus b. You just, instead of adding, you would subtract, or instead of subtracting, you would add. So negative 1 minus root 5, the conjugate would be negative 1 plus root 5. And again, we're multiplying by 1, so we want to make sure we do that over itself. And in our denominator, we have quite the process we've got to go about here, right? We have to FOIL. In the numerator, we have to just flat out distribute. So when we get to the FOILing, you'll see why this conjugate situation helps get rid of the radical. But for now, let's focus on the numerator. Root 3 times negative 1 is negative root 3. Root 3 times root 5 is root 15. So there's your numerator. Denominator, we have to FOIL. Negative 1 times negative 1 is 1. Negative 1 times root 5 is negative root 5. And your inners, negative root 5 times negative 1 is a positive root 5. And negative root 5 times positive root 5 is negative 5, right? Root 5 times root 5 is just 5. Are my radicals gone in the denominator? Not yet, but what do you notice about them? They cancel. So therein lies the beauty of conjugates. When you multiply conjugates by each other, the outer and the inners will cancel. So to be truthful with you, I will almost never do the outer and the inner and actually write it down because they'll just always cancel if you've done the conjugates. And then so our denominator is just 1 minus 5, which is negative 4. Any questions? Okay. In number 7, what's the conjugate here that I would multiply by, Angie? Yep, negative 2 plus root 5 over negative 2 plus root 5. Little annoying because I have to now FOIL in both locations. So starting with the numerator, 2 times negative 2, negative 4. 2 times root 5, 2 root 5. Negative root 3 times negative 2 is positive 2 root 3. Negative root 3 times positive root 5 is negative root 15. Can I combine anything up there? Or simplify anything up there? No, so that's just going to be a really long numerator. On the other hand, your denominator, negative 2 times negative 2 is 4. And as promised, I'm not going to write this next step down. Negative 2 times root 5 would have been negative 2 root 5. Negative root 5 times negative 2 would have been positive 2 root 5. The negative 2 root 5, the positive 2 root 5 would have canceled. So my outer and my inner, when I FOIL, I can just ignore. And negative root 5 times positive root 5 is minus 5, right? Root 5 times root 5. And 4 minus 5 is just negative 1. Guess what? They'll never leave a fraction over negative 1. They'll just, truthfully, they'll divide every term by the negative 1. So negative 4 divided by negative 1 would be 4. Then it would be minus 2 root 5 and minus 2 root 3 and plus a root 15. Good? Last but not least, what's the conjugate on 8, Lucas K?
Negative 7, positive 3. Oh, wait, negative square root 7 plus.
No. You don't negate both of them. You just switch minus to plus or plus to minus. Like, go back to this one. It started as a negative 1. It stayed a negative 1. It's just the minus root 5 became a plus root 5.
Okay, so then it'd be just square root 7 plus the square root 3.
Good. Very good. Now, again, noticing that my denominator was not originally in parentheses, but I immediately lock it up because I want to make sure I remember to FOIL and distribute. Yes? All right. That would be the end of that. In the event that we were going to have extra time, I was going to review a 3-variable system. No big deal.